Yeah, I have to manually connect this every time. What the F? Well, thanks for telling me. Probably should get that fixed, but... Again, that was very lame. So I really have been explaining everything what I'm doing. That's about microphones or... Right, so what was I doing? So now we're dividing by 0 because d is 0. Yeah, thanks Carlo with a wonderful name for telling me. I'll reiterate a little bit what I said, because otherwise maybe you have no idea. So we're trying to... I'm trying to apply my new function, which is called find extreme, which finds the extremes, either a minimum or a maximum of a third degree polynomial fit, for which I need 2 points, because each point also has a derivative. So you have 2 points with the slope, then you can fit a third degree polynomial through it. And right now I'm worried about the case where that third degree polynomial is actually a parabola, aka the coefficient of the x to the power 3 part is 0. And then the code just fails. Now that is the case with this function, which this function is a perfect parabola here, up till this point, and then it switches to, with a little bit of S shape here, to a different parabola. So you have a parabola here and a parabola there, and they're just perfect parabolas, and they are connected here somehow. So as long as I stay on this side, the next point is here, sample point, and then we fit a parabola that goes through here, goes like that. And then the fit is a parabola, not a cubic. So yeah, then my code starts crashing. So I press space, we get the next point, and then the whole thing stops. And the reason is because my third degree thing, well, it was before very small, but now I forced it to 0. Doesn't print it, but actually we just have this parabola now. And then the question is how to deal with that. So no, that means that d is 0. So yeah, I cannot define that. Cannot divide by it. That is, one of them is actually 0 divided by 0. And that has a limit. So I need to find that limit. Or I can just redo the whole thing here. Assuming we have just a parabola. Okay, I'm not happy with the waiting until we are dividing by 0. I think that if the thing just becomes way too large, then... So if you divide by 10 to the power minus 14, for example, then one of those becomes extremely large and the other one is actually close to the correct limit. But yeah, if one of them tends to go to plus or minus infinity, then how accurate is the other one? Because that then is a very small number divided by a very small number. So I think that I should probably... I mean, it's like literally C. Yeah, I think that that's a very good way to test it. I think if if the value of the square root of d is close to the absolute value of c itself, that means that you would have a big well, very small difference here. So then the floating point round off is going to be significant. Let's say 1 billionth or something like that. I think we have like a double has like 20 digits accuracy, but I must say I only see 15 usually. 5 digits is more than enough, or 6. So if I do 9, 10 to the power minus 9 is the difference, then yeah, that's good. So just waving, how do you call that? I don't know what the expression is. I'm slowly getting senile, so. There's the expression waving a dead chicken, but that's voodoo, and that means that you're doing something that nobody understands. Which is not the case here. So it's something else. Well, a wet thumb, or is that a Dutch expression? Okay, so if the standard absolute value of c minus the standard absolute value of the square root of d is less than 10 to the power, wait, 1e minus 9 times standard absolute value of c. Which would not be the case if c is 0 as well, of course. So I should not really use c. I should no, I should not use c. Let's say c is 0 and the square root of is 1 billionth, or yeah, less than that. Then this is going to be less than 1 billionth, and this is going to be 0. So it's not less than. That is a problem. Why? I think we're really talking about the absolute thing. Man, what do you even want here? I want them to be equal. I can compare them equal with an absolute error of is not really a problem, actually. One of them is 0, then that subtraction is very accurate. So if then one of them, neither of them is not a number, not a number, then there is actually no problem. But it still feels super asymmetrical, I must say, to use c instead of the square root of d. I mean, what? You can make it symmetrical, maybe? No. Damn it, you have to understand this before you can code it. Yeah, it's like literally, I could just literally use the average value here. So making it symmetric again, I would say I'm just adding this one. And then divide it by 2 or not. And then we have the average value, and at least now it's symmetrical, more or less. But then, of course, you can still have the problem that they are just exactly the opposite value of each other. This one's always positive, right? It's a bloody square root. Why am I taking the absolute value of that? The question is then if one is minus the other one, then this would still be 0, and though we still wouldn't have anything to compare with. So then you have this must be positive. That doesn't make sense either. Sorry, I have to use the. I'm going to use this. Minus C. Let's keep the same order. No, wait a minute. This looked reasonable because I was thinking in terms of the difference, but it's the one that reaches 0 here. So it's either this one or that one, and that happens when this equals that one in absolute value. So I sorry, it was not correct. I really have to do the square root of D minus the absolute value of C. Why do I have so many braces? Now I wrote a utility that is equal to almost equal, called almost equal, which does this. So the difference divided by the average. That's the absolute relative error, which is then passed as the second argument. But yeah, this thing does use the absolute value of the difference. So maybe it's not suitable. Anyway, if you look at this formula that I came up with, then the difference divided by that is then this value. So this is my absolute relative value. And then I can just use the same insights that I had here. So 2 times the difference is less than or equal absolute relative error times the absolute value of the sum. Except that now I do not add them, I take the absolute value of the separately, and then I add it, and so I don't have to use I don't have to take the absolute value of the sum anymore, because this is already positive. Include 15. And then this is the still need to take the absolute value of this, right? Because this could be negative. That's not a good thing. Oh, so that's what's going on. Yeah, I just have to work with the absolute value of C. Okay, now I can finally use the... Yeah. Okay, so utils almost equal the square root of D and the standard absolute value of C. 10e minus 9, is that totally looks wrong? Probably like that. Yeah. Okay. Yeah, because this if this is almost equal, then that gives me the floating point round-off error that is unacceptable. So in this case, we're going to use a parabolic approximation, which I already have. That is, we are in approximation, which also has a parabola being fitted. So I think I should use that then. Instead of the cubic, we use the parabola. And then we have to do something that still kind of mimics the idea behind this function. So in the end, this function returns a result which is equal to the minimum or maximum that it picks. It's just the vertex. So now my result is the vertex of the parabola. So in the end, I want to return that. If we return anything, then we will return the vertex of the parabola. I guess the thing has a vertex. No, x. Yeah, it appears. I don't know why it's called x here. Quadratic polynomial. Okay, let's approach this differently. My parabola is a quadratic polynomial. Right, and that has a vertex x. Yep. But well, when do I want to return that? Well, only if it is the requested one. So now I have to look at this again. I already did a lot of filtering on those H and direction and extreme values. Can I not use that still? Can I not just use a standard infinity and then in the end make sure that I don't return that, or is that nonsense? If I use standard infinity, then it's going to return that if I request it. I don't want it. Yeah, there must be an easier way. There's no easier way, so. Let's go backwards. So I was already doing it backwards. If we return something, it must be the vertex. That also means that I can assign the extreme. That is then either up or down, depending on if this is a minimum or not. A minimum or a maximum. This is what we want to assign if there is no solution. And this is what we want to assign if there are solutions. To go back to the problem. Come on, I'm sure I had a is maximum, or maybe another class had that. Seems I don't have it. Oh, I just added it to the approximation itself, I think. It's a bit lame, but yeah, has maximum there. I think I should return rename this parabola as maximum. Because now we have both. A cubic and a parabola. Getting the feeling that I have to redo all of this code and not parabolic approximation. That can't be good. I'm confused to see this. This looks like initializing parabola. Already did that. Why is that happening here as well? Yeah, and then H direction. There's no in between, or is there an in between? Yeah, of course, it can be an in between. Right, let's say double vertex is this thing, which you then return. And then I still need these then. Yeah, this is the same code as this. Less than W is just left. If it is larger, it's right, and otherwise it's in between. Maybe I should copy it exactly like this. Maybe better. So it is larger than WR. Then it is right. Otherwise in between. In the end, machine learning ship home. That's what gradient descent is being used for, isn't it? So if we return the vertex, then this is the extraction. And this is the extreme type. And this is the value. So why would I not return this? Well, I would not return this if the extreme does not match the one that we want, for example. Or the extraction doesn't match what you want. So I can't just assign them because I need to know what we want, and that is stored in the same variables. So I have to come up with another. So these are just passed by reference, so they are both input and output variables. So let's make up a new one. H direction out, I guess, is something, and then V direction extreme out is something. And we can assign those things. They are independent, so I might as well swap there. Oh boy, now it doesn't fit anymore. Swap the order. So, okay. And then reject it if it is not, well, maybe you couldn't reject it first. So let's start with that one. So if the extreme out is unequal extreme, that would be the requested one. Then reject, which means that extreme must be set to vertical direction unknown, and return something undefined. I think I have this already, right? I don't. What the hell? Yeah, extreme is vertical direction unknown. Yeah, type something wrong, I guess. Undo, redo. Ah, space too much. Okay. And then, but then we return indeed just nothing. So okay, so that would work. But of course, this is only the case if the extreme is unequal, unknown to begin with. This is the requested extreme. So an unknown kind of means don't care. So if you don't care what that is, then it doesn't matter if it is equal or not. Well, that can't even compare it then. And here we have horizontal direction out is that, and then when does that match? Well, if the input horizontal direction, just H direction, is unequal undecided, because then again I don't care, and we can just return it whatever H direction is. But if it's unequal undecided, and well, if it is unequal undecided, then in between is always good. So, and then also H direction out cannot be equal to in between. And now we can do the same as here. So H direction is unequal what is requested. Then again I want to reject it. Otherwise, well, we can return. So H direction is H direction out. Do it in the same order. Extreme out is extreme. And return the vertex. Okay, let's check it again. So if this thing is almost per parabola, then I'm going to print this. Otherwise, I don't know if the code is even used. Cubic is cubic. Cubic underscore. Get the vertex. Extreme out is going to be up if the parabola is a maximum or has a maximum. Down otherwise if the requested extreme is not unknown. And we requested something else than that we already found. Then set it to unknown to signify that we could not find anything and return nothing. And I probably okay, wait a minute. Maybe I should set H direction as well. Okay, anyway, then we set H direction out is left, right, otherwise in between. And if the requested H direction is not undecided, and the output is not in between, and they differ, then reject it as well, otherwise return it. So the only thing that's missing is in some cases I want to set age direction even though I return unknown for the extreme. Tough. No, no. We only do that here if d is less than 0. So I should not do that here because we're already past that point. Feels like it could make sense though. Ta-da, we don't crash anymore. So now we have this parabolic fit, whatever, through 0 and 1. And let me see. So the cubic is a parabola, and it says using parabolic approximation. Yep. And then it returns downhill. You're gonna be kidding me. That is 4. It doesn't jump to the vertex. Yeah, what? Minus 4.9 is here. That is the vertex. So it's not going just downhill, not knowing where the vertex is. No, it jumps to the vertex. It should not say downhill. Why does it print downhill? Otherwise it seems okay. Let me see if it actually jumps there. I think so. No, it jumped here. What? What's up jumped here? I don't even see that point. What the? Minus 4.8. My history isn't working anymore. I add stuff to the history, but don't see the points. They should be visible in the graph. Appending to history, point 2 at 4.88. It's all bullshit. What is happening? Oh, okay, code doesn't work. Apparently, despite using the parabola, it is returning that it couldn't find anything. But then it should have done that, which is maybe the reason we overshoot the vertex. No, I cannot follow this whatsoever. Let's run this in the debugger. See what the hell is happening. Set a breakpoint at 108. I set a breakpoint at 108 and I get 10232. I meant, of course, 108 in algorithm.cxx. Okay, this is after returning point 1 has been returned, so point 0 is at 12 and the next point is 10.6, so now we have a parabola fit, which is shown here. And then the cubic has a tiny itchy thingy there, but I set that to 0, so we get the same thing for the cubic. And then I guess we call find extreme. All those handles are just drawing events. Here the whole approximation was done. And then we call, we don't call find extreme yet. I just re-enter this, the entry point of the algorithm with a W value of 10.6. Okay, so the local H direction here to undecided and this to unknown. And a forced cubic to be exactly 0, although I could remove this line now, I think. 10 to the... Where's my cubic? 10 to the power minus 14, that is somewhere here. It's all already too small. No. And then equal find extreme. Okay. Step. Long find extreme. Number of relative samples must be 2. Get the cubic. Find ID is 0 indeed. We do have solutions. And then one of them cannot be calculated. So I have a actually maybe neither can be calculated. Yeah, dividing by 0 in both cases. So both are not. The WR is 12 and the WL is 10.6. And then we enter here. Cubic is that using parabolic approximation. So now the vertex is -3.5. Well, it didn't update the drawing, but I think this parabola is like this, and then yeah, the vertex is here, 3 minus 3.5. So extreme out should be down. And then immediately we detect that this is... No, it's not, because this is unknown. So I don't really care about which it is, so we just do next. And then we get this one. And that's also skipped because the current H direction is undecided. Equals undecided. So then we set H direction out to H direction, which is undecided. Wait a minute. What is this? It's a destructor or something. No. It's just an enum. What? I don't know. Next. Let's do it again. No, we had 2, no, 2 or 9. Really weird. Okay, so we set this to down. Oh! Yeah, okay, never mind. Quit, yes. Yeah, out is clearly not the best name here. This one was already good. This is like input and output. That's more like the result then. Maybe I should rename it to result. Optional result. Yeah. That's better. So this was the parabolic fit, and we jump to the vertex. And the blue arrow here means that we dropped even further than what we expected. And now we have something that is not a problem. I think the red thing is the parabola fit through 2 in 1. And the magenta fit here is the cubic fit through 2 in 1. And we are now looking for, I think still nothing, right? But then it should be using the nearest extreme, which is, well, this minimum. 2 minus 5.6, yeah. No, I'm not convinced. I would say this is more like here. I don't know what it... Yeah, what? Oh, it's using parabolic approximation. Yeah, that's wrong. Okay, yeah, I'm still forcing the last coefficient of my cubic to 0. Let's not do that. I forgot where I did that. Damn it. I have no idea. Cubic something is 0. Well, something. Oh, there I did it. No, I didn't. Actually, no, I didn't. This is the one, of course. Totally. Okay, there we go again. Blip. Jump. Okay, so now it returned minus 7.6, which is definitely then not the extreme, the vertex of this problem fit, but it really uses the correct one now, the minimum of the third degree one. Yeah, and it's called find extreme jump. What was then the previous one? Also find extreme jump. Really? Minus 3? Well, maybe. No. Gotta be kidding me. So it's not using the parabolic approximation despite this super low value. Well, it works, so apparently it's not a billionth there at that point, the difference. No, okay. Jump again. Block. And again, it does a find extreme jump. And this time to the actual correct value. Almost. The correct value is minus 7.75. And then again, that's ridiculous. Yeah, hello, 100k Flutter. Are you going to continue floating? I'm writing a program that tries to find the minimum of this function. Minus 7.75 is the correct value. I'm not happy with that. It has a point here, and then again a point here, and now again a point here. I mean, it seems a bit like a waste. I had the feeling that it was like way faster when I just used the parabolic approximations. And again, come on. Oh, no, it just okay, never mind. I deleted the code, commented out the code that detects that we have found the minimum. So it's going to stick here forever. Okay, that all makes sense. Yep. Well, then I guess this works. It finds the minimum, although it gets stuck there then. try another one. Not found. If one. Why not? Oh, the last one is just else. Yeah. To then make this a 1. So what should this do? I think it's gonna fit something. I think it's going to go down and then fit something that I don't know. Yeah. I must say that the third degree polynomial is way better than the second degree polynomial. This one has a minimum like way not where we want to go, and this one is almost already where we want to go. Is that not good to development? So I think that with this thing being here, we probably will jump to the minimum here, right? Yes, we do. And then obviously the minimum is even better. Now we jump there, and then we get stuck there again forever because we are in the minimum. So this one finds finds the nearest minimum. Yeah, well, okay. I could try to start it a little bit to the right. If I start here, and then I think it's going upwards, right? First step is down, and then we would have a fit, and then the nearest extreme is going to be a maximum. I think I want to see that. So let's put it on, I know this is 15, 14. I think 14 will work. No, that went down, but almost nothing. And now we jump there. Beep, yeah, it's finding a maximum and getting stuck there. No, let's try another test. I have nothing better to do. Sure, this is going to this maximum, I suppose. No. Yeah, what? It's 45. It went to this minimum. Why? Okay, what happened? We went from -40 to -44. Okay, that's a very big jump. And then the nearest extreme was probably the minimum. After that, yeah. I think I'm going to go for a walk or something, because not enough exercise here. And then I can think about what to do next. It's also cloudy in my head. I have no clear picture, so it's horrible. Oh yeah, I think I had one more test or not. I only have one. Yeah, this one. But that's, I think, a simple one. Yeah, okay. Well, it is an interesting one. Sure, this one is saying, oh no, wait a minute. We are here. So on average we are here, and then this maximum is closer than this minimum, apparently. So it's jumping to 0.7, which is there. And then we get stuck in that maximum again. Yep. Okay, well, actually, this is interesting. At the very least, in this case, I could pass that we want to go to a minimum. You know, I say I don't care, and then it goes to the closest extreme. But if I say I want to go to a minimum, I insist to go to a minimum, then what will happen? Pattern not found. Nope. Got to go to algorithm. No, not algorithm. Where do I go to? Actually, I do go to algorithm, I think. Yep, there's my find extreme. So instead of passing, I don't care. I'm gonna say I want to go down. That's interesting. I mean, I think... Well, you can already see where the next point is. It's 5.9, so here. So apparently the magenta 30-degree thing here is horizontally there. It goes like, I don't know, like this. So we're going to jump to that point now. That point, 5.9. And I have no idea what happened. The next jump is to minus 46. Really? Really? Doesn't look like it's fitted anything through point 2, I must say. No, it did. Something. Okay, what a miss. Finally we're there. Oh no, not even. Dude, what is happening? And then it settles on this mirror. Okay, yeah, you can learn from this one, because it's absolute horror. My God, what is happening here? We should make a small step downwards. Well, small, all the way here, but why not? And then this curve has apparently a minimum here, so we jump there. And now I should detect that there must be a minimum between 1 and 2, because, my god, even the slopes are opposite. But it seems that it didn't even update my third degree polynomial. It's just the old one. What? Okay, so the last point was the 5.9, and then what the F happened? Which points do we have? Fit through 2.7 and 5.9. Yep. And opposite slopes, opposite signs of the derivative. And that gives me a cubic like that. Maybe it would help if I printed where the zeros are of this thing. Oh, this happened. Scale update disconnected. Reset. Oh, we did a reset. Yeah, that should not happen. The whole idea of my new code is that I'm perfectly fine with this overshoot. It should just say, well, we go from 1 to 2. I mean, there's nothing wrong with that. It's very obvious that we missed this minimum. I think the disconnect comes from missing the parabola fit. Yeah, I had a parabola fit here. And then we jump to 2, and then it says, yeah, the point 2 has nothing to do anymore with the previous parabola. That's what the disconnect means. But I don't care anymore, so I have to remove that. Well, actually, I do care. If there is a disconnect with the third degree, and there's also a disconnect with the third degree, but yeah, I don't know. The point is we have to go back. There's no reason to start to reset and not use this point. I want to find the minimum that is on the right of this point. So that's completely stupidity then to do a reset and start over at this point, which is even higher than that one, while we're looking for a minimum. This makes no sense whatsoever. So I should say, okay, point 2 is not lower than the lowest point that we found so far. It doesn't... Yeah, no, no. It should just do a new fit and then jump back. I'm going for a walk. It seems to be a story without end. It's getting no fun anymore, actually. It's just taking way too long to come up with a good algorithm. Feeling so stupid. Going for a walk means playing chess. Because, well, you have to give in to your addiction to chess. Shall I play until I lose, or shall I just play one game? Or does it matter? I don't think it matters. It's just probably the exact same thing. Watch me push this pawn. Yep. Ooh. Yeah, I would like to play this one. I can. Why do I not move? And then you can put that knight in the corner. Maybe he wants to push this one. Then I want to be able to push this. Let me put something here. Blunt is bishop. Well, if he pushes it 1 and I push, then it's still blocked. I just do this. Kick the knight. Keep the knight at bay. And you could still put it there. Let's do that first. Oh yeah, castle. Castle there. Yes, of course. Don't be scared. Still push it right. I have to develop something, but what? What shall we develop? Of course, he can't allow this. He's going to push this pawn 1, and then I push this one, and then he has a problem. Incredible problem, but I need to make use of it. I don't know how. Let's start with this. Seems a bit nonsensical, but well. Since I'm only using moving pawns, might as well continue with this. It's time I really develop something. Well, it's true. Well, not really true, actually. Where's that thing going tonight? Nobody knows. Oh, there. Yeah, I could have anticipated that. Once back. Oh, now I can do this. He cannot push anymore because he blocked that. He's not doing that, strangely enough. Let's develop first. The bad bishop moved. Maybe I should take here and then put a knight there. Nah. Can do this. It's not good. Maybe I should castle short. And stop him from moving his pawn forward. Yeah, and this knight belongs there, of course. very, very, very clearly. Okay, so I go here and he pushes this pawn. I take, he takes, maybe I just take the knight, he takes, then I have to go there or there. I'm not ready for that. Whoa! Now I want to go here. Totally threatening this ball now, am I not? Oh, like that. The a-hole. Okay, yeah, damn it. Damn it. Couldn't I have done that immediately? It was a good game, and then he gave away a piece. And I didn't even see it immediately. How did that happen? I have no clue. Well, thank you. Now he gives up. Yeah, well, I think I'm going to go for a walk because this is not even making me happier. I think it was super bad, my position, before he gave away all this stuff. I could just take it there already. Unbelievable. I could take it. One move. I haven't I haven't seen I could take the free bishop for like ever. Oh my god. Yeah, unbelievable. I'm completely chess blind. Oops. White is better. +2 because this move, yeah, he just encapsulates his own bishop. Entomb, as they call that. Still +2. Wasn't even a bad move then, apparently. I went back, that wasn't the best move. What should I have done? Bishop to a very unclear place, yeah. Maybe push this one or something. Probably. Oops, so I went back. And then again, +2. Didn't do that, and then he gave away bishop. And I didn't see it. Unbelievable. And he gave it away again, and I didn't see it. And he gave it away again. Well, sort of. This is a 2 on a row, so I can just that is attacked is not even problematic. I still did not see it. Oh, this is so bad. Okay, now I had to exchange, but I still didn't see it. And now, because my knight is attacked, I finally saw that there's a free bishop here. How sad is that? Oh my god, I'm depressed by this game. That's not how I want to win. Okay, I'll be back.